In this video, we'll take a closer look at HTTP requests. For desktop application, input can come from many sources like keyboard, mouse, webcam, and so on. But for web applications, the main source of input is HTTP requests. So we need to have a very good understanding of HTTP requests and what we can do with it. To see what a HTTP request looks like, you can use the developer tools provided by your browser. For example, I'm using Microsoft Edge browser here, which is based on Google Chrome. So both Edge and Chrome and Firefox, and I think Safari also provides developer tools. Go to here and go to developer tools. And there are several tabs in developer tools. If you want to look at requests and responses, you want to go to the network tab. So let's clear network tab and let's go load a web page. I have a web page here called test.html. It's a simple HTML file on the CS3 server under my account. And the URL for that one is CS3 and test.html. So if I go to that URL, so notice that if you only look at the browser window, there's not much you can see other than the content of the file. But if you look at the developer tools, it actually tells you that the browser actually sent two requests, one to test.html, and it also sends a second request, go to favicon.ico. So that's the favorite icon of a website, and by default, the browser will try to load that, and I don't have that on my server, so this one returns a file not found. And if you click on here, you can see the request and response. So this one shows the response, but if you click header, it will show you the request header, response header, and so on. So this is one way of looking at HTTP requests and responses using the browser developer tools. Browser developer tools are very convenient, but to show what HTTP requests and response really look like, I usually prefer using a tool provided by Eclipse called TCP/IP Monitor because it shows requests and responses in a more raw form. TCP/IP Monitor functions like a proxy server that sits between the client and the server. Instead of sending a request directly to the server, like you would normally do, the client sends a request to the TCP/IP monitor, and the TCP/IP monitor then forwards it to the server, and similarly, the request is sent back to the TCP/IP monitor, which then relays it back to the client. So what's the benefit of having TCP/IP monitor as a middleman? Well, in our case, it allows us to examine HTTP requests and responses. So now let's set up TCP/IP monitor and see how to use it to monitor the access of a web page. So TCP/IP monitor can be found in Eclipse's preferences, which is kind of an odd place to put a monitoring tool, but I guess there's no better place for it. To set up a monitor, we need to provide a few parameters. So now remember that a TCP/IP monitor needs to forward the request to a server, so it needs to know where the server is, and that is the host name and the port. So our server will be cs3.calstate.la, and port will be 80, and type, of course, is HTTP. we'll leave timeout to default. 0 basically means connection will not time out, or in other words, the monitor will wait as long as necessary for the server to respond. And then also remember that TCP/IP monitor functions as a server itself, so it can receive requests from the client. Therefore, it also needs its own host name and port number. The host name is always localhost because it's running on the local computer, and the port number can be anything as long as it's not already taken by some other services. So here we will use 5000 as our local monitoring port. So now we have the monitor set up and we can start it. Right now, nothing happens, and let's try to access this page again. Let me touch the page so that the web server will send back the full page instead of page not changed response. And so this time we are using the TCP/IP monitor. So remember, instead of sending the request directly to the server, now we want to send the request to the TCP/IP monitor. And the TCP/IP monitor is located at localhost and port 5000. So we go there and we get the same page back. The interesting things is in here. So now the request goes through TCP/IP monitor, so the TCP/IP monitor captures the request, which is here, and on the left-hand side is the request, on the right-hand side is the response. By default, the request and response headers are not shown, so we can go to the menu here and check show headers, and now we can see the request headers here and response headers here, and this is a request body which is empty. This is a response body which shows the web page, and we can change this one to byte, and it will show the response body in its byte form instead of trying to display it like a page. So this time we'll focus on the request part. Then next time we'll talk more about responses. So if we take a look at what a request looks like, it basically looks like this, and it consists of 3 parts. The first line in an HTTP request is called a request line, and then is followed by a number of headers, or number of headers here, and then is followed by a optional request body. So sometimes this request body has data, most of the time it doesn't. In the request line, there are 3 things: method, request URI, and protocol. As we can see here, method, request URI, and protocol. Request URI here is what we usually call path, and we know that in static web it's used to look up a web page on the server, and for dynamic web it's used to map a request to a server-side program like a servlet. Protocol is a protocol used by the request, and most of the requests these days use HTTP 1.1 protocol. You can think of request method as the type of the request. For example, there are GET requests, POST requests, and so on. The term method is used because it indicates the action to be performed on the resource identified by the request URI. For example, GET means to get or retrieve the resource identified by the URI, and we can see why GET requests are the most common because most of the time we want to get a web page. But sometimes we may also post some data to a web resource, for example, posting a reply to a topic in a web forum, and then naturally those requests will use the post method. In this class, we'll only deal with GET and POST requests, but the HTTP standard also defines some other methods. For example, PUT is intended for placing a web page at a URL, and the delete is intended for deleting the web page at a URL. You can imagine that these two methods could be used by some HTML editors that put or delete web pages directly on a server. And then there are methods that are used for diagnosing the server or the network, like head, options, and trace. Now that we know the request methods, it now makes perfect sense that why the servlet methods are called doGet, doPost, and so on. Basically, whenever a request comes in, the service method in the servlet will be invoked, and based on the request method, the request is then dispatched to one of the do something methods. We've seen using doGet method so far because most of the web requests are GET requests. The default implementation of these do something methods in HTTP servlet simply returns a bad request error. Web programs like our servlets typically need to handle GET requests or POST requests, or both. If your servlet handles both types of requests but produces the same response, you can put the code in one method and then simply call that method in the other one. After the request line, there are a bunch of request headers which look like this. In this class, we don't deal with request headers much, but there are a few important headers that you should be aware of. For example, you may need to check the user agent header if you want to serve different content to different browsers. User agent header tells the server what type of browser the user is using. And cookie is very important for tracking sessions, which we'll discuss in a different video. If a user clicks on a link on a web page, the referral header will be containing the URL of that web page, and that information is very useful for online advertisers because this one tells them where their traffic comes from. When you have time, you should take a quick look at the HTTP specification and get a general idea of what these headers are. Now that we know what a HTTP request looks like, let's take a look at HttpServletRequest. And remember, that one is the type of the request parameter we get in the doGet, doPost methods. And this is the input of our program. And so needless to say, it's very, very important that we have a good idea of what we can get out of this. So this is the API documentation for HTTP servlet request. First of all, notice that it's an interface. It's not a class, but in any case, we can call many methods of this. There are lots of methods in here, and most of them called get something. Get context mask, get cookies, get header, get date header, get header names, and so on and so forth. So as you can imagine, these methods let us access various information included in a HTTP request. So let's do a simple example and see what we can get out of our request. So I have a new project here, and let's create a servlet. And the package, I'm going to put it under 30-20 servlet, and we'll call it request info. And this one will have to get, to post. Let's get rid of the unnecessary comments. So as we can see, the default code template generated by Eclipse give us both doGet and doPost, and the doPost simply calls doGet, which is fine, regardless of whether the incoming request is a get request or post request. We do the same thing. So here we want to know the request method, request URI, and some other information. So before we do that, let me copy this part of the code so that we don't have to write too much. We will display, we will set content type and get the output, and then start writing. And this one I'll call it request info. And let's first print out the request method. So we'll say request method is, and request, of course you can get method. This gives us the request method. And what else do we want to know? URI, okay. So let's say we get request. There's a URI and then there's a URL. So let's see what's the difference. This one is URI, and this one is URL. And we also want the IP address of the client. So IP address of the client, if you look at the HTTP servlet request interface, we don't actually get something like that. It says we can get the remote user, but that's it. However, notice that HTTP servlet request is a subclass or subinterface of servlet request, and servlet request has a whole bunch of methods of its own, which are inherited by the HTTP servlet request. So if we look here, we can see that we can do something called get remote address. So that presumably will give us the client address. So we will do that, and we'll say the client address is get remote address, And then we want to determine if gzip compression is supported by the browser, and that is in one of the headers. So if you look at the headers, there's a header called accept encoding, and it says gzip, deflate, and br. So that means it accepts the response in several formats, and the response can be compressed using the gzip compression, and the browser can decompress it later, and this saves bandwidth. So we are going to take this one and check this header and see whether the value of the header contains gzip. So it will be something like this. We'll do a get header, and the name of the header will be called accept encoding, and this one will give us the value of the header, which is everything here, and then we can check if gzip is in there. There are different ways of doing that, and we'll use index of to check, and if this one not date header, we want a string header, and this one will give us the index of gzip if it's in the string. Otherwise, I think it returns 0, return -1 if it's not in the string. So this one will check whether it's greater than 0 or greater than equal to 0. Okay, so I think it's greater than or equal to 0. It means this is in the string, and then we can do gzip supported. So this, and then we can say either it is supported or it's not supported. We'll print out gzip encoding is supported, else it will say it's not supported, something like that. Okay, so let's run this. Okay, so it says the request method is get, so it's a get request, and the URI is this one, so it's basically the path component of the URL, and this is the full URL, and the client address is this weird looking thing. So it's basically said the client address is localhost, and this is the IP version 6 IP address of localhost, and gzip encoding is indeed supported. That means gzip is part of the accept encoding header. So this is how we can get some information out of HTTP servlet request. Again, remember this is the input of our program, and you need to be fairly familiar of the API of HTTP servlet request. So that's good. We know how to get headers, we know how to get request method, and so on. But although request headers contain lots of information, the more general way to get user input is actually using request parameters. We have talked about request parameters before when we discussed HTML forms. Please review the HTML form lecture if you forgot about them. The short version is that request parameters can be specified directly as part of the URL called the query string, which can contain a list of parameter names and values. And they can also come from HTML forms. When a form is submitted, the form fields are submitted as request parameters. Let's create a servlet that adds two integers from request parameters and display the sum. We'll use this example to show how to submit request parameters and how to handle them in the servlet. Oops, wrong. Let's create another servlet, and this servlet is going to be simply add. Okay, I'll just call it add. Again, I'm going to copy over this code for display. Okay, so this one is add, and add two integer values provided by request parameters. So the first question, of course, is how do we get request parameters? And that, of course, rely on some methods provided in HttpServletRequest or ServletRequest. And these are the methods in ServletRequest that are related to getting parameters and their names, their values, and so on. The most commonly used one is this, where we specify a parameter name and get the parameter value as a string. Notice that it always gets the parameter value as a string, and if it's something else like an integer, we have to do the conversion ourselves. And there are a few other methods, like you can get all the request parameters as an enumeration, and then you can iterate through the names. You can also get all the parameters as a map with parameter name as a key and the parameter values as the value. But the other most commonly used one is this one, get parameter values. So this one will specify the parameter name and return one single string value, and this one will you specify the parameter name and it returns a number of values. You may be wondering how come a parameter give back a number of values, and that's because HTTP requests actually allow multiple parameters having the same name but different values. For example, if you remember, when you create checkboxes, all of the checkboxes will have the same name, but they could have different values. So this method is quite useful if you have a form with checkboxes and you want to get all the checked checkbox values. So in our case, we'll just use get parameter, and so here we'll do something like this. We'll say the first value is going to be called A, and we'll do a request get parameter, and the name of the parameter is up to us. I'm going to name the parameter A, and notice that it returns an integer. So if I want a integer, this message returns a string, and if I want an integer, I have to do an integer plus int. And we'll do the same thing with b, and the sum, of course, is a plus b, and then we can say the sum of a and b is something like that. So if we run this, so we immediately got an exception, and it says null. And the reason why it says null is very simple, because we don't have any parameter called a or b. So request get parameter will be return a null, and if we try to pass an integer out of null, we get exception. And to fix that, we can simply provide a couple of parameters, and once we have that, we can get 10 and 20 and 30. So this is I guess the first lesson. Web programming is still programming, so all the things that you did before still apply here. That means you should check for null values and handle if and else cases and so on. So for example, if we have to do it, we'll have to do something like this. We'll have to say SA is request get parameter A, and SB is request get parameter B, and if SA is null, then we set A to some default value and so on. So I'm not going to do that just to save some time, but just know that there's no magic in web programming. If you get something that's null, you have to check for that condition. So this is one way of supplying request parameters. We can actually just type it in the address bar, and this is how to handle it. But of course, more often than not, you wouldn't want your users to manually type in some parameters in the address bar. So what you want to do is, of course, use a form. And let's create a form. And this form, I will call it add form. So again, if you forgot about HTML forms, please review that video or that lecture. And the short version is that for a form tag, you need to provide two attributes, action and method. And the action is the URL of the server-side program that will process the request. So in here, it will be the URL of this servlet, and we can use a relative URL here because they are in the same project. So we'll use the relative URL add, which will submit to the servlet, and the method will be the method of the request that will be used to submit the form, and the two methods that are commonly used are get and post. and now we know why they are called get and post. They are the methods of the request. So let's try get first. And inside the form, we can say A is, let's say, name. Remember, name will be the name of the request parameter, so we'll call it A here. And B is going to be called B. And then let's also put a button that says add. And if we go to add form.html, we can see this is our form, and let's put a couple of values there. Let's do 101 plus 2, and if we click add, we get 101 and 2 is 103. Pay attention to the address bar. Notice that although we are supplying the parameters using a form, when the form is submitted, the parameters are actually submitted as query strings. And this is what get methods do. When you specify the form to use get method to submit the form, the request parameters are actually submitted using query string. What if we change this one to post? And so let's refresh and let's do 202 plus 4. So 202 plus 4 is 206, and it still works. And notice that this time we're using a post. First thing to understand is that if we use a post request to submit a form, doPost will handle the request. In here, doPost simply pass the request and the response to doGet because they're doing the same thing. So doGet will just do what it does, getting the request parameter, printing out the sum, and so on. But do understand that if the request is a post request, it will be handled by doPost, as the name says. That's the first thing. The second thing to note is that this time, if you look at the address bar, notice that the request parameters are no longer in the query string. And that's because in a post request, request parameters are actually sent in request value. To see how that works, we can actually use our TCP IP monitor again. Let me stop this and then edit this. And this time we'll use it to proxy localhost 8080. So this one will be localhost 8080. And then let's, is it start? Is it started? Let me start this. So in other words, we are going to use TCP IP monitor to proxy this one. And then here, I'll change the action to localhost 5000. And then what's the, and this one. So this time we're going to submit to the TCP IP monitor so that we can see the request and response in here. And let's try and see if this thing works. So refresh, and we'll say 200 and 100, and so it does work, and it does captures the request. So notice that now this request is a post request that goes to add, a bunch of headers, but also notice that now the request body is no longer empty. So unlike this one where the request body is empty, this one, the request body actually is not empty. And notice that the request parameters are encoded in the request body for a post request. But regardless of whether the request parameters are in the URL query string or inside the request body, in the servlet code, we can always use request get parameter to get it, regardless of where the parameters are. So that's a pretty convenient thing. Okay, so let's quickly recap what we have covered in this video. We have seen what a HTTP request looks like. It has a request line, some headers, and optionally a request body. It's important that you know request methods like get, post, pull, delete, what they mean. We have also seen how to submit request parameters, either in query string or using a form, and also how to process them in a servlet using methods like get parameter or in some cases get parameter values. And believe it or not, after this we are actually ready to do some serious web programming, which we'll see in the next video.